Hi, welcome to my channel, JaberTime. The remainder and the factor theorems. We're going to talk about the remainder and how to get the remainder and the benefit of knowing if the remainder is 0 in factoring. Let's get started. f of x divided by g of x equals q of x, the quotient, plus some remainder r of x out of g of x. As a view, this is what we have, which we all know as a long division. Now, just to see with numbers if it makes sense, 35 or 32 divided by 5 as a long division looks like 5 into 32 gives you 6. 6 times 5 will give you 30. And when you subtract 32 minus 30, you get 2. So that's my quotient, that's my remainder. Just applying the same format right here with numbers. So 32 divided by 5, 32 divided by 5 equals 6 plus 2 over 5, which is 6 plus 0.4, 6.4. Try it on your calculator. 32 divided by 5, you get 6.4. So that's the formal way of doing it. Now, why we start this way? Because we have in the second slide the benefit moving on to the factor theorem. Now, we're not going to divide by g of x. Mainly today we're going to divide by x minus a as like knowing one of the factors. A factor of the polynomial instead of p of x polynomial. If a factor is x minus a, like x minus 2, we need to find the other factors. Well, hopefully this is a factor, which means there is no remainder. That's the idea. So, if you multiply all three terms by x minus a, on the left side, this cancels, and this cancels. So I get a cleaner look. P of x, our polynomial, will end up our factor times q of x plus some remainder. But that's not going to be a factor if you do have a remainder. Alright? Because when you factor, you don't have remainders. So the game is so simple. For example, p of x equals x to the second minus 8x plus 22. If x minus a equals x minus 5. Let's see if x minus 5 is a factor. Well, doing the long division, and I'm skipping the steps, just want to give you the concept. Dividing by x minus 5, we have x minus 3. But we do have a remainder. So what does that say? It says that our polynomial is equal to x minus 5 times x minus 3 plus the remainder. Here we go. Now multiply these two just to verify that this is true the way we write it down. We know how to multiply using the FOIL method or distributive. I have x to the second, I have minus 3x and minus 5x minus 8x. Minus 3 times minus 5 positive 15, but we need to bring the 7 down. 15 and 7 will take me back to 22 as our original polynomial. So what we're doing or rewriting this is accurate. This is true. This is true. Now, let's take it to the new slide. That's what we have. Now, if x minus 2 is a factor, that means x equals 2 is a root or a 0, where the graph crosses the x-axis. So by testing that and plugging in here a, that a, look what happens. We're gonna replace x with a's. But a minus a is 0. So this will cancel. Something times 0 is 0. And that is what we have. In a cleaner look, P of A equals R. So if A is a root, when you plug it in, it should give you a 0. But if you plug it in and you get a number, that's not going to be a root. That's exactly what I'm trying to say here. Now, since we're dividing by x minus a, the best way to look at it is not the long division, is the synthetic division. And this is what we have. So P of A equals R. That's the remainder. So if you use the synthetic division and divide by A, thinking that we're trying to see if we divide by x minus a as a long division, we get a remainder or not. That tells me exactly if there is a remainder or not. What does that mean? I know I'm saying it, but let's write it down. So in words, for a polynomial p of x and a number a, the remainder upon division by x minus a is P of A. Let's practice and take some examples. Use synthetic division or substitution to find P of negative 3 or f of negative 3. If f of x equals the following, that's my polynomial. So I'm gonna take my time and show you step by step. Writing the notes as I'm recording, I tried this before, it takes too long. 30 minutes will end up like over an hour. So hopefully my notes with a lot of examples written are helpful to save you some time. Trying to give you as many examples as I can to show you to practice. Let's get started. For the synthetic division, if you're not familiar with the synthetic division and need some practice, I'm taking it step by step. You have to be careful sometimes when you are missing a term. You see the term right here? This is the 4th degree, this is 2nd degree, so we're missing the 3rd degree. This is exactly what I mean. So, we write the coefficients. Negative 2 goes right here. My a, which is negative 3, goes outside. Negative 2, 0, you don't want to miss the 0. 3, negative 15, and 9. What do? We take the negative 2 down. Alright? We multiply negative 2 times negative 3, which is positive 6. We put it right there. We add, going down, that's a 6. We multiply 6 times negative 3, and that's negative 18, goes right there. We add, going down, negative 18 and 3 is negative 15. We multiply negative 15 times negative 3, which is positive 45. We add, going down, that's a positive 30, right there. We multiply 30 times negative 3, which is negative 90. We add, going down, 9 minus 90 is negative 81, and that's our remainder, which is the value of f of a or p of a, and that should do it. Let's practice more. Another example. Show that x plus 8 is a factor of the following. I'm not reading it to save you some time. Then find the remaining factors of the polynomial. We need to identify what goes outside, which is a. And let's see how could we find a. X minus a is now written as x plus 8. So we need to see this with a minus. You don't have to, but just want to make sure that you don't take a as 8. It's actually what comes after the minus. Was supposed to be negative 8, but simplified to positive 8. So a is negative 8. That goes right there. Now we're not missing terms, as you could see. Third, second, first constant. So we should be fine. We'll put the numbers one after the other. 2, 15, negative 11, and negative 24. First step, what do we do with the 2? Bring it down. Multiply 2 times negative 8. Goes right there, negative 16. Going down, add them, that's negative 1. Multiply negative 1 times negative 8. Put it right there, that's positive 8. Add going down, that's negative 3. Multiply negative 3 times negative 8. Positive 24. Add going down, that's a 0. Since they say show that x plus 8 is a factor, that means when you divide by it, you don't get a remainder. So the remainder should be expected to be 0. So, how do we read this? If it's written as long division, I would say it's easier. But once you get used to it, right here, you should be fine. That's my polynomial without the x's. We're dividing by x plus 8. And that's my quotient, and that's my remainder. So how do you rewrite this? Here we go. Because the remainder is 0, x plus 8 is a factor. Of course, if you have a remainder, what we are dividing by is not a factor. Makes sense. By the factor theorem. So that connects both the factor theorem and the remainder idea and the concept. So, we could write 2x cubed plus 15x to the second minus 11x minus 24 as the following. We are dividing by x plus 8, and we got this as a quotient. And we write this as 2x to the second minus x minus 3. And we are done. I have more examples. I'm halfway on my video. So let's keep going. Given the polynomial x cubed minus x to the second minus 10x minus 8, we're not missing any terms, so we should be fine. And one of its factors, this is a factor, which means we should end up with 0 here. No remainders. But we need to identify a and be careful with a. Since x plus 2 equals x minus a should be negative 2. That goes right there. You know the rules. I'm going to go a little bit faster, but just follow me and practice. We write the coefficients 1, negative 1, negative 10, negative 8 right here. 1, negative 1, negative 10, negative 8. We bring that one down. We multiply 1 times negative 2. That's negative 2. Add going down, negative 3. Multiply negative 3 times negative 2, positive 6. Add going down, minus 4. Multiply negative 4 times negative 2, positive 8, 0 as expected. What does that mean? This is a factor. X plus 2 is a factor. Because we are dividing as long division by x plus 2. The other, or the quotient, or the other factor is down below. We're going to write it with x's. So our polynomial is equal to x plus 2 times x squared minus 3x minus 4. But this is factorable. It's x times x and 4 times 1 to give me a negative 3 with a minus for the 4 to end up with by combining like terms to negative 3x. And we're done. One more example. Given the polynomial x cubed plus 2x squared minus x minus 2, we're not missing any terms, so we should be fine. So, one more time, we're dividing by x plus 2, so we're going to write minus 2 outside. and here we go, minus 2 outside. The coefficients goes right here, 1, 2, negative 1, negative 2. 1, 2, negative 1, negative 2. We bring the 1 down. 1 times negative 2, negative 2. Add going down, 0. 0 times negative 2, 0. Add going down, negative 1. Negative 1 times negative 2, positive 2. Add going down, 0, as expected, because I was told that this is a factor. So I should not get any remainder. The remainder should be 0. So here's our polynomial. It's factorable. One factor was x plus 2. The other factor is down below right here. And this simplifies to the following: 0x minus 1. As you can see, 0x minus 1, 1x squared. I believe this is a difference of 2 squares, looking at 1 as 1 to the second. And we know how to factor difference of 2 squares, which is a minus b times a plus b. And that should do it. I still have more examples. And let's move on. Given the polynomial x cubed minus 19x plus 30. Oh, we're missing x to the second. Just be careful. And one of its factors. So this is a factor. Today a is 2, not negative 2. That's like x minus a. So a is 2. A is 2. Don't forget that we are missing an x to the second. Alright? So we have to make a place for the 0 as a placeholder. 1, 0, negative 19, and 30. What do we do with the 1? Bring it down. 1 times 2 is 2. Add going down, 2. 2 times 2 is 4. Add going down, negative 15. Negative 15 times 2, negative 30, add 0. They told me one of the factors. That means I should end up with 0. So our polynomial is equal to one of the factors, x minus 2, and the other factor comes from these 3 numbers. If this is factorable, we'll continue. I think it's factorable. 15 is 5 times 3 to lead me to a 2. But one of them should be minus, and we'll give the plus to the bigger one to end up with positive 5x and negative 3x, which combines to positive 2x. And that should do it. I tried my best not to go over 30 minutes, and it looks like it's about 19 minutes. Thank you.
Thank you for watching. If you like this video, hit the like button and subscribe, and I'll see you next time. Thank you.